Okay, so this is College Algebra, November 2nd already. Tomorrow is election day. Oh, but we're not going to talk about the election right now. And we're going to do chapter 5.4 today. It's actually a very, very fun chapter. 5.4, it's right here. Yeah. Properties of logarithmic functions. I didn't check. Elizabeth said that there is no like time goal sets. It's possible. I remember I didn't set them all the way, maybe. Need to check. But we still have the objective. So I hope you guys on the Zoom have been doing some Alex. Okay, so let's get the bigger pen. So there are several properties and they're really cool. First, let's remember what logarithm was. What is logarithm of 5 with base 5 of 625? What does this equal to? Don't need calculator for that. Anybody? Elizabeth is thinking, but anybody else there?
125?
No. It's a good try. So what does the logarithm asks? It asks, Timothy, do you have answer? Or if the cat has an answer, she might know.
Well, it would be the fifth root of 625, right?
Is it? It's not.
No, am I remembering this wrong?
No, it is wrong. Okay. The question is 5. Okay, let's write this as exponential. This is right here we have logarithmic expression. This is logarithmic expression. So let's say this is x. I want to know, the answer I was looking for is x. So if you write this as exponential, expression would be 5 to the power of x equals 625. So this is the same thing, but written as exponential notation. So what is x?
4.
That's correct. Right. Okay, so this is what the logarithm does, is ask you the base to which exponent gives you the number inside. And if it doesn't make sense to you, you can always rewrite it as exponential expression, not notation, exponential expression. Or you can rewrite the logarithm as exponent. Then it can make more sense to you. Okay, now properties of those logarithms. Okay. They're super fun. There are several properties. The first one, let's use a Roman numeral, would be logarithm base a of two numbers multiplied. A, m times n. This is times would equal. I'm writing capital L, I don't know why, but okay. Logarithm a m. Logarithm a n. In other words, if we have a product inside the logarithm, right here, this would be equivalent of the sum of the two separate logarithms, right? This is also called expanding the logarithm. You expanded the first one, which is kind of short, you made it long, so you expanded it. Expanded form. Okay, expanded it. So let's see how it works. For example, we're going to get, I'm using the book, so we're on page 435. And let's get example 1, which says find, sample 1. Find logarithm with base 3 of 9 times 27. So what you can do, because 9 times 27 is a big number, but you can actually use this property and split it in two logarithms. So it's going to be log 3 9 plus log 327. So what is log 39? This is easy.
3
No, it's not.
or 2.
2 is 2. Okay. Log. So the first one is 2 because 3 to the power of 2 is 9. How about the next one? Log 3 of 27.
That one would be 3.
This is 3. Okay. So the whole thing equals 5. Right. This is the answer. The answer is 5. Right. So here, because this thing is 2 and this is 3. Okay. So some easy case. Another one would be what would be what they didn't give me more examples. Let's do a backwards one. I'll give you longer expression and you need to now condense it. You do it backwards now, going from the long to the short. Okay. Let's see. For example, let's say we have logarithm with base a of p plus logarithm with base a of q. Oh no, let's see. Let's write a word. Hold on. P O. Oh, oops. Of O plus logarithm with base a of t. Okay. So what would this be? So combine them. We need to go backwards. Instead of expanding, you need to condense this. So what would this equal to? Anybody? Yeah. Yeah, or pot. This how we spell pot like marijuana. Okay. And this is not my intention, but if you were a secular college, this would have been very exciting problem for.
Hey, it could be cast iron. Who knows?
Okay, but this, I was thinking about cast iron, but then I thought, oh wait, it's pot too. So you can, when your kids were studying this, or you can explain to them the rules of logarithms and then write different riddles. Okay. Okay, so this is for people who like literature more than math. You can do this. Okay. Now the next rule. Okay. Again, just notice the base is always the same. The base does not change. Right? It's always A. If the bases are different, you cannot do this. Okay. This was rule number 1. I hope you took note because I am erasing everything. So rule number 2, regla numero 2. No, what is the regla? Is it true? Oh, okay, good. I remember this. Okay, so it's called the power rule. Here's a name. We don't really care about the name, but it is on page 436. It's very important rule. Okay, logarithm base a of, oh my god, so many letters. Okay, they say m to the power of p. See this? So what's inside the logarithm is m to the power of p. This whole thing is inside, right? So this would be, so this is the row. The exponent is going to jump in front. So it's going to be p logarithm am. So I'll try to make it more visual. So this p, the exponent always jumps in front right here. And I'm going to get rid of those yellow parentheses. Okay. Do you see it? Okay. So let's do some practice. Let's practice some. Okay. I'm going to get, okay. Example 3. It says express each of those as a product. So I have logarithm, oops. We have logarithm with base a of 11 to the power of -3. So they say express this as a product. In other words, move the exponent front. Can we make this? That's correct. Yeah. Okay. So you can do the same thing. You know, you can go backwards. If I give you a pronoun, say, you know, like, put, yeah. Yeah, let's do another one, a little trickier. The next one is logarithm A, base A, of 4th root of 7. And you need to do the same thing. They're saying express this as a product. So what are we going to do? Any suggestions?
Turn it into a fraction and then put it behind the log.
What kind
A
of
fraction with an fraction in the exponent. So that'd be 1/4.
Okay, so then 1/4 goes in front, so it's 1/4 log A7. Beautiful thing, beautiful. This is probably the easiest thing. You know, it's super easy. And if you have done intermediate algebra recently, you probably remember it because we did it there. Do you remember, Elizabeth? She remembers. Okay. Okay, dokie. So let's learn one more rule. And then we are going to just do crazy examples. Okay. The next rule is the quotient rule. Okay, number 3. It's quotient, which is associated with division, and you can probably guess it if you have logarithm with base A of m over n. So this would be logarithm of m minus logarithm of n. The order matters though, so make sure you know the numerator is first. And the one which is in the denominator is with a negative. Right. This is the rule. So let's say, let's do example. Let's make it a little, okay, let's do example, a single example. Let's not overdo it. Express as a single logarithm. So I need to condense it. I'll say condense. So I need to condense this logarithm with base B of 64 minus logarithm with base B of 16. See if you can condense this. Anybody?
That would be log 64 over 16.
Yeah, let's simplify. This is 4, right? Because 64 divided by 16 is 4. Okay. This way, okay. So now we're going to jump and do crazy stuff. Okay, ready? So this is remember the movie RV with Robin Williams? I explained to you when we
I
studied,
remember this.
yeah, when we studied this in intermediate algebra. So you need to, you know, put the stuff out when you're stopping, and then when you're leaving, you need to put everything in. I'm talking about the exponents. Okay, so let's do this. Express in terms of sums of difference. Example 6, page 437. Example 6. Okay, let's start. Logarithm with base A of x squared to y to the 5th z to the 4th. Okay, you expand. Now expand it. Everything needs to go out, which can go out. See what you can do. Okay. I found out that if I pause the recording, it actually stops the video. Maybe it doesn't. Okay, I'll stop the video while students are working. Pause. I'm pausing the video. Yeah. So what did you got? Who? Elizabeth? Let's see what Elizabeth got.
I got 2
Okay. Okay.
plus 5
Okay.
minus 4
Okay. Did you get this, Tim?
I did not.
What did you do? Do you want to write? Can you write on the screen?
I don't think I can. I made a mistake. I just I ended up with like 14 or something.
Jeez. Alicia, did you get it?
Yeah, I have the same answer.
Or we've got this answer. Okay. Timothy, I don't know how we got 14, but all you do, split them first into, you know, the multiplication, and then the one which in the denominator is with the minus, and then you can take out the exponents.
I just didn't split them into different logs. I forgot to do that.
Oh, okay. No, you did it correct. So the first thing, doesn't matter. The first thing is to do the multiplication here. The exponent would be later. You cannot take exponents at first. So like the first step would be to split it like x squared plus, doesn't matter the order really, as long as this is the step you're doing. You can do y5 and then minus, but you need to have minus, so in front of the z1. Yeah, first, and then, because you can take the exponents only if you have a single logarithm, right? If there were, you cannot, because see, this one goes out, and this one, and this one. Yeah, because if you can here, you cannot, because this 2 is only for the x, is not for the 5. So we're going to do one, we're going to put them back. Like for example, let's see, if you have this one, logarithm with base a of x cubed y fifth, right? So you cannot take the exponents now, right? Because again, if you take the 3 is just for the x, is not for the y. But if you put it in front, you can, if you put it back, it seems like it's for the whole thing, right? Okay. Let's do another example. Now we're going to have to put them together. It's example 6. Oh, actually, no, we're going to do B. Okay, I'm doing example 6B. Example 6B. About B. Whoa. Logarithm with base here. This is a good one. Okay. Cube root of 3 a squared b over c to the 5th. I mean, I'm like ready to do it, but give it a try. What do you think we need to do first? Now there is something you need to do first, which is different than what I just said earlier. It's a different case. You can do this actually 2 ways, but the most straightforward. Yeah, that's right. So first, the first thing you need to deal with this cube root, because this cube root encompasses the whole inside of the logarithm, right? So see this? Okay. So now we can do it 2 ways. And the best ways, probably, I don't know which one is the best, actually decide. The first is, we're going to do it 2 ways. One will be here, the other will be here. Okay. First, we get this in front, right? If you do this, let's make this single. Then we are going to have 1/3, and then in parentheses, kinda, because you're going to split this one, right? A squared plus logarithm AB minus logarithm C5, right? Do you agree, everybody? This is one way again.
Yes.
And then here, the next, what you need to do, then you're going to take the exponents out now, right? Still have 1/3 2 log AA plus log AB minus 5. Oops. See, right? Because this came out. Yeah. So then the next thing you're going to multiply the 1/3. So it's going to be 2 over 3. What is logarithm of with base A of A?
1.
1. It is 1. This is 1. So essentially, The first term is 2 over 3. Okay, plus 1/3 logarithm of AB minus 5 over 3 log AC. Okay, this is one way to do it, when you take the exponent out first. The other way, let's do it right here. Let's do pink, I guess. Oops. So the other way would be, if you, so I'm starting from here, the other way would be, if I actually decide, instead of taking the 1/3 in front, you can actually distribute the 1/3 to each one of those little like terms inside. So you can do this here, and this right here, right? It's the other way. So this would be, writing with pink, so it's going to be logarithm with base a of a to the power of 2 over 3 times b to the power of 1 over 3 over c to the power of 5 over 3. Do you understand? You're using the one of the properties of exponent. Then if you have a to the power of x, y, this is a to the power of xy, right? This is what
I
we
think
were.
the first one is easier.
Yeah, I think the first one is easy, but you know, if you do it this way, then some people will different, you know. If you do it this way, you can just split it now, and you're going to have, you know, log a 2 over 3 plus log b 1 over 3 minus log c. And then take the exponents out, and you're going to get the same thing we got. Where do you see this? Oh, it's plus. Oh, good catch. I make mistakes all the time. So does Joshua's teacher in school. Sometimes we don't say it. I mean, I can guess the mistakes only in the math homework, and he gets marked wrong, and I'm like, oh, this is right, but it's okay. So are we? Do we have questions? She does, but I didn't tell her she's wrong. Okay. This is actually a thought that many teachers. I think we should stop the recording when I'm sharing my experience in life. This is my recording. Okay, so the next example 7. It's super easy. We just need to condense it. They say express as a single logarithm. The book says express as a single logarithm. This is example 7, page 438. Okay, so you can write it and condense it. So this is like the RV movie applies here very well. I just have such a visual. This movie is so much fun. Elisha, have you seen the movie RV?
Yes.
Oh, this is B. No, but it really applies to math. And so whenever I do those problems, I just keep thinking of this movie and keep laughing in my silently. But it is Z. Right. Because now we need to put the exponents first. This is the key. If you don't do this, you mess it up. This one too, right? The exponents. So this is what happened in the movie. They were in a rush to escape from this couple who was trying to be nice to them. They're like, go, go, and they forgot to push back in the awning of the RV, right? And then hit the pole and broke. Okay. So push those things in. You're going to get log bx5, and you can do this in one step. I'm just going to write steps. If you can see it in your head, just do the whole thing at once, because you can kind of envision them going. Exponent is going to be single logarithm with base b of. So the one with the minus will just go in the denominator, right? And the one with plus would stay on top. We can do the fourth root, I guess, to make it look more complicated. Timothy, did you get this?
Yep.
Okay, Elizabeth has a question. What is it?
Why do we put the z to the fourth on the top and not at the bottom of the y when it's
Because it's a plus right here. And when it's a positive, it stays on top. Because it was like you can rearrange those. Okay, let's see. If you rearrange, you can put those together. Imagine, you know, it's totally legal. So you have logarithm b x to the 5 plus logarithm b z to 1/4 minus logarithm b y. So then if you do then use the rules for the logarithms, you just multiply those, right? x5 z 1/4, and then this is on the bottom.
yeah, I just thought that because it was like after y, that
Yeah.
it would be x to the
No.
y.
Yeah. If it was the case, then you needed to have that. You had to have parentheses right here, right? Because this applies for the whole thing. But I'll give you another key to that is. Let's see.
Does it matter what rule we use to express it?
No. I'm not what you're saying exactly, but it doesn't matter what rule as long as you get it.
Okay.
Good. But so this is what another thing, you know, if you don't want to get confused about exponents, you can think of, if you have a negative in front of logarithm, let's say bx2, right? Think of the negative as -1, right? So what you can do, you can take this -1 and put it back in as exponent, right? So this is going to be -1 here, right? So then the whole thing would be, go back to the green, would be logarithm b x to the -2, which is 1/x², right? Logarithm b 1/x². So when you multiply this to another one, it will be on the bottom anyways. Kind of. Okay, now is the, oh, well, let's do the challenge. Okay. So you're going to see how I condensed the logarithms and got one thing. So think of a joke or think of something. So you can write, and you can use letters, right? Instead of exponent 5, you can do like logarithm with base a of k to the power of p or whatever you want, right? Or you can put the p here, right? So write the problem in expanded form, like let's say plus, you know how I wrote the pot? Let's see. For example, like that, I wrote like, if I want to write team, let's see. I'll do t. No, I won't do this. Okay, logarithm. What would be? This is hard, but I want to write team, but I put the t here actually. Then I put the I right here. Let's put the I right here. And then plus logarithm, let's leave it base 10, the logarithm of m, right? So if you combine this would be logarithm of tim, right? Tim. So think of something, think of a word, and I'll give you 5 minutes and write the problem like that. See who can come up with the best problem. It doesn't need to be too long, just think of some kind of word. Okay, let's make the rules what kind of word, like movie name or food, okay. So you're going to write the problem like this, the name of your favorite food. You need to write it like that. You know, you need to have more letters, obviously. But, and then you're going to write it for us on the board or tell us what it is. You can write it in the chat and we're going to try to guess it. Got it? Okay, let's pause the video while this is going on.
Oh, you record as soon as my bad handwriting comes up. I see.
Okay, I forgot. The first, so our team is writing. Elizabeth wrote the word apple. We're like, oh, this is boring. We expected something like tortillas or.
Oh, mine's not going to be that much better.
Oh.
So it'd be.
What is it? Tacos?
Yes.
Ah. So Tim is way. More Mexican. Alicia, did you get something?
I did. I just don't know how accurate it is.
Well, can you write or we need to write for you?
I don't know. I don't know how he wrote.
It's a button called annotate. Tim, can you tell her where it is?
If you look up, do you see where it says viewing Robert Nash's screen that's got view options?
Yeah.
You click view options and then there's a button that says annotate.
Mine doesn't. Mine says original size or request remote control.
Maybe are you on the phone or an iPad or something?
I'm on my laptop.
Weird. Oh well. Oh, tell me what it is.
Okay, I got H log
H?
B.
H log. Wait.
Yeah.
H log what?
B.
B as a boy or P as a?
Oh, B as in cat.
Oh, cat. Okay. And then?
Plus C as in cat. Log I. Plus E log K.
E
Plus
like
log
this.
N.
Log K.
Yeah.
Plus what is the last one?
Plus log N.
Okay. Can somebody guess it? This is H.
Is it fried or grilled?
Oh, is
Yeah.
it chicken?
Yes.
Okay, we got it. Okay. Okay, moving on. What's the time? Okay. Oh, I see the time. Hey guys, how do you enjoy the new time? The 1 extra hour? I'm enjoying it. No, I like it.
I hate daylight
Good?
savings time with a passion.
No,
I just do.
But in the morning it's easier to wake up, at least for a week. Okay, let's do, now we're going to do example 8. Okay, this was the fun part. Now still, this is still fun. On page 438, okay, let's do expresses a single logarithm. So we have this thingy there, logarithm 3x plus 1, oh, excuse, minus. Okay. So you need to express as a single logarithm, and then you need to factor it and cancel it. Oh. Well, first you write it as a logarithm. This is natural log, but it doesn't matter what log it is. So when you have quadratic like expressions and linear factors or linear like expressions, you should see if you can factor it. And this one is the mean one. We just do a quick quadratic formula here. Let's make it in orange. It's 5 plus or minus, I'm factoring the denominator. Square root of 25 minus, it's going to be plus 4 times 2 times 3 over 6, right? So this would be 5 plus or minus 25, oops, plus 24, which is nice. All right, so this would be 5 plus or minus square root of 49 over 6, which is 5 plus or minus 7 over 6, which is 5 and 7 is 12 over 6, which is 2, and the other one is minus 2 over 6, which is minus 1 over 3. So this means that I just found the roots of the denominator. I'm using the long way to factor it, the quadratic formula. So this means that I can factor this into, one of the terms would be 2, right? So x minus 2, but the other one would be, okay, I'll just put it right here. Okay, it's going to be x plus 1 over 3, right? And then the 3 needs to move up, right? So it's going to be 3x plus 1, which would cancel with the top one, right? Oh, let's just write it here. Okay. This would equal logarithm of 3x plus 1 over x minus 2, 3x plus 1. So you see factoring even came here. Here we go. So the whole thing is logarithm of 1 over x minus 2. Yes, you can have those. Okay, the next type, oh my gosh, there are more? Oh, wow. Oh, I didn't see there so many. Oh, let's see them. Okay. Next one. Okay, example 9. So this example is very easy, just you need to understand what is asked of you. Example 9, page 439. Okay. It says, given that, so they tell you that logarithm with base a of 2 is 0.301. It's approximate actually like that. And that logarithm with base a of 3, it's approximately equal to 0.477. Find each of the following. Okay, so first a, let's do blue. Find, okay, let's do 1. Find what is logarithm of with base a of 6. So what do you need to do? You need to use, the only thing you can use are those two logarithms. So how we're going to find what's logarithm a of 6? By using those two things. What you can do, you're going to write 6 as 2 times 3, right? Then you're going to split it. And then instead of logarithm a2 or logarithm a3, you're going to write what they equal to, which is 0.301, and this is 0.477. And when you add them, you're going to get 0.778. All right. Okay. Interesting. Yeah, let's do B. See if you can do B, which is number 2. Number 2, you need to use those two expressions, the pink ones, to find logarithm with base a of 2 over 3. See if you can do it. Do we have questions on the Zoom?
No questions.
Okay, see if you can do this one. Logarithm a 2 over 3 using only those two expressions. Everybody got it? Yeah, I need to subtract them. Okay,
Is it negative 0.176?
that's correct. Negative 0.176. I'm going to write it. Okay, try to do number 3 or C. There, the equal signs are all like at the end. Like, okay, so we're doing number C, which is logarithm of 81. So how are we going to do this? I'm giving you a clue. 81 is a power of something, 3 to the power of something. Three to the power of what is 81? Six too much. What is 81? 81 is 9 times 9, which is 3 times 3. So yeah, it's 10 to the power of 4. And when you do the 4 in front, I guess the whole thing would be 4 logarithm A3. Yeah, and then you can substitute this logarithm A3 with 0.477. Okay. Wow, I know. And then continue. Let's do E. Okay, I'm jumping to E, which is 1, 2, 3, 4, 5, the fifth one. We're going to try to do E. Okay, I mean erase. Oh, I erased my thing, but okay, I know what we're talking about. Example 9. So E is logarithm A5. How can you use the two logarithms to get this? Okay.
You just add them, right?
What is it, Tim?
Just add them, right?
What do you add? What do you add?
Logarithm 2 plus logarithm 3.
So this is the mistake you should not make, and that's why I was successfully quiet. Okay, this is no, because 5. Yeah, 5. If this was true, then 2 times 3 needs to be 5, right? But it's not. Because you cannot, you know, if this is a no, and they had it somewhere, I'll show on which page, but if you have this, I mean, sorry. 3 plus 2, this does not equal logarithm 3 plus logarithm 2, right? If they are added, this is no, right? The rule was only for logarithm 2 times 3. Then it's right. So in this case, actually, the answer is cannot be found using these properties. So the answer is no, we cannot find it. All right. Okay. You have those knowledge and you will, that is it, you do them. Okay. So next one would be, you have at the end. There's something we did already, but let's say if you have logarithm with base a of a to the power of x, what does this equal to, you think? Anybody? Quick answer.
X.
It is equals x, yeah, because if you do the steps, Tim, there are two ways to find out. One is you're doing inverse of the function, right? Because remember, this is the exponential function, and this is the logarithmic function. So you're essentially having f minus 1 of f of x. You're getting the x, but you know, it's kind of deep thought. Instead of that, you can just do the rules, which are, yeah, oops. Yeah, we're going to move the x, so it's going to be x log AA, which is 1. So just came up with x times 1, which is x. All right. Just remember this one. It's just easier. Remember. Okay, the next one is, I guess we need to practice it. Okay, let's practice this. Okay, logarithm 10 to the power of 3k. What would this equal to? This is example 10C. What is this? Anybody? This is logarithm with base 10. If the base is not there, means the base is 10.
That would just be 3k, right?
Yeah, just 3k, yeah, because you know, this is 10, it's going to be 1. Okay. Okay, so how about this one? Natural log of e to the power of minus t. What would this equal to?
Minus t.
Right, it's negative t. Because natural log essentially has e as a base, so it's e t. Okay, very good. Another one. Okay. The last one is really cool, but the proof is kind of long. We won't prove it, but let's see if you believe me, it's true. Okay. A to the power logarithm with base a of x equals x. Right. So what it is, the proof is right there on page 440. But if you think about it, you have exponential function, right? A to the power of something, this is the exponential, and the exponent, you know, a to the power of x, this exponential function, and your x is actually the logarithmic function, which is the inverse of the exponential. So you have f of f minus 1 of x technically, which is x. Or you can think of it as the logarithm just cancels. Hold on, let's erase this. Oh, erase this. You don't want to erase that. See this? You can just think of it as the logarithm and the exponent cancel, and just we have the x. Okay, these are the two cases where only x is left. So let's look at example 11. You can do example 11. I don't know, let's do A. What is the answer for A? And I need to write it out. Okay, the answer is K. How about B? What's the answer for 5? Okay. And how about C? Where is C goes? What? That's correct, 70. Because the base is 10, you don't see it, but it's 10. Okay, so these were the rules for the logarithms. And they're easy. All you need to do is to practice. Practice and practice more. Yes, so let's see. There is a really nice problem though in the book. I feel like we have to do it. Okay, one more problem. And then we see, Elizabeth, you can show me what you need to say. I'm going to do on page, you're going to do on page 442. Let's do problem 52. See 52? Let's do it. I'll try to write it. 52, so 120. And then, oh gosh, logarithm. Root of x cubed. Whoever does this first wins Halloween candy. And since you're not here, I can eat it for you. 3. These are from his candy. Logarithm of 4. 16. Get to business, Elizabeth. You're here. You can get a candy. I have Twix. What's the name? I have all the good ones. Here you go. See who can. What it says? It says expresses a single logarithm. Haha. You write it correctly. Log 4, 16, Z5. Yeah, yeah. Okay. Okay. I'll wait. Are you working on it, team? Work. What would you do? I suggest leave the 120 in front until the last moment. Make the exponents rational. I know. So actually, let's make it a little higher here. To give it a try, you can do this. So the 120. Okay. Not too bad. This is the key now to do this right. Okay. Next line, I'll make it pink. Okay. So you want to write it as a single expression. We can do this at once. Okay, should we do the 120 or not? It's a question of preference. I think I'll do the 120 at the end. So I'm combining those, giant logarithm, top. I'm going to do my 120 now. Okay. So see, they're not too many. This is my third line. So I'm going to put the 120. So what happens? I want to write the whole thing. I guess I'll write it. It's going to be logarithm. The 120 will just do this, right here. Okay, so now we need to apply the rules for the exponents, which tells you that you need to multiply the 120 by each exponent here. See this one. Okay, so the next line would be, I'll write it under here so you can see it. Okay. Logarithm of x to the power of 3 over 5 times 120, right? Oops. And they're nice numbers because they kind of simplify. And then it's y 2 over 3 times 120. And then 16z5 1 over 4 times 120. So when you do this, 5 divided by 120 divided by 5. Oh, it doesn't. What is it? Okay. This 120 divided by 5. I'm getting crazy. It's 24. So the first one would be x to the power of 3 times 24. Right. Then y. The reason this is not so bad is because 120 divides by each of the fractional denominators here, the fractional exponents denominator. 3 divided by 140, 120 is 40, so it's going to be 2 times 40, and the denominator would be 16z to the 5th, the whole thing. 120 divided by 4 is 30, right? So now I need to multiply. Let's make it green right here. Equals. So it's going to be x to the power of 72, I hope. Y to the power of 80. And now, oh my God, we need to do 16 to the power of 30. And z to the power of, it was 5. Z to the power of 150. Jeez. Let's look at the answer. It's correct. No, it's not. I need to get 2 to the power of 120. Oh, yeah, because they made the 16 into the power of, they made this 16. You can, but you don't have to, but I don't know if Alex wants it. 16 is 2 to the power of 4. So then the whole thing, when you multiply by 30, would be 2 to the power of 120 instead of 60. So the answer would be, instead of this 16 to the 30, would be 2 to the 120. Right there. Okay, well, that's enough for this. Okay, so I'm going to stop the recording for this chapter. And we're going to look at the problem Elizabeth has. What did they do? Okay. Okay. How do we stop